Welcome. This is the framework of a lesson plan that I did with my Math 055 students this semester. I was demonstrating this up at on the visualizer with my Nspire and encouraging them to do some of the graphing on their graphing calculators using their TI 83s and 84s that they had. I didn't see much higher than that as far as what they were using. But in any case, the goal here was to help them understand why we factor to solve quadratics and why it's important for them to be in the standard form ax squared plus bx plus c equals 0, as well as to hopefully get them to start making the connection again between the graphical representation and the algebraic representation of a function and what these values mean. So actually, I've got a couple of steps here that I didn't have when I actually started the process, but at the beginning of class I gave them this quadratic, asked them to solve it using factoring, and they did. And then I asked them if any of them had wondered why we needed to use factoring in order to solve them and what it really means to be a root or a zero of the function. And being that they were Math 055 students, they weren't that interested. But when I asked them if they would like to have a quick, easy way to visually see whether or not a quadratic is factorable and to double check the roots that they find, that seemed to get them excited. So I think in the future that's how I'll launch. In any case, so what I did is I just opened up a graph page, and here's the graph of the function that they had just factored and solved for. And again, I was asked them questions about the graph. What does the graph represent? Eventually they did get to the graph is all of the ordered pairs. If we put an x into this function, then out comes a y value, and this is a kind of a record of all of those values. Next, I asked where on the graph is the function equal to 0. And some people wanted to say this point here. Eventually we did get to where it's intersecting the x-axis, because again the value of the function is the y value and y is 0 on the x-axis. So that once we had that down, I did go ahead and put in intersection points here, and as well as their values. I'm going to move those up here, because then what I did is I went ahead and did a new page layout and did the split screen, and down here I added a notes page and insert the math box and showed how I can that up here we have this listed as F1. So here I'm just going to put F1 of x. And there's our function. And here it is written as a quadratic without it being an equation, because there's no equals sign here. It's just showing what that is. And then I can also use calculations, algebra, and factor, use the factor property, and put in here F1 of x. And there's the factored form. And in addition to that, we can also put in algebra, solve F1 of x, and this will give us the, oops, not quite right, comma x, and oops, equals 0. So here we have solve f1 of x equals 0 for x, and there are the roots. So again, I asked them again, when we're finding the roots, what are we actually finding? And eventually we got to that. Again, they were looking for the x values that, when the function is evaluated for that value of x, that we get 0, and that that's represented here on our graph by the intersection points. So now I know did go ahead, oops, escape here, and just grabbed this and started to slide back and forth, and again, so that the students could see as I slide back and forth here, or up or down, that anytime I stop, that again, these values here, -9, -5.7, are going to be matching in our factored form and are the same as our roots. And again, I asked, oh, I shouldn't say again, but I also asked them what the difference between these numbers were. They did point out that the signs were different, and I asked them why those signs were different, and it took a little while for them to say that, oh, well, this number, when I put it in 4x in this factor, the factor goes to 0, and then the whole thing goes to 0. I think they're still kind of locked in this idea that whatever this value is, I have to put it into all of these x's and figure all of this out. They're still not quite making, or they weren't anyway that day, quite making the connection that these things were equivalent, and I could put x in for these x's and have the same values if I put them in for these x's. So that was kind of a surprise that they struggled with that. In any case, I did not do much as far as pulling, and because what I found is that it really starts to get a mess. And additionally, the factoring pulls that lead coefficient out, and so you're still actually working with monic. Like it'll factor this out and give you a monic polynomial, and then it's factoring the monic rather than leaving these coefficients in front of the x. So I didn't like that because that's not how they're going to do the problem. I did so I did this on my own, but then I realized this isn't going to be very good, helpful for them. So I wouldn't recommend doing that. But what I did do is then come back up here, and we experimented with some other functions that were on their handout. I had given them a worksheet of a variety of functions, excuse me, quadratics rather, and so here was another one. Is x squared. So again, this is another monic, plus 7x. Plus 12. And before I went ahead with this, I asked them again, since this is monic, we're expecting our factors to be an x something, another x something, and because we have a positive here, then we knew that the signs had to be the same, and since this is positive, we knew that those signs had to be plus and plus. So we knew that just from that, we knew that something about what we would expect these factors to be, and then I said, well, if both of them are plus, what would we expect the x values to be if we want them to go to 0? And they said, oh, well, then the x has to be negative. So that made me quite happy. And here it is. Again, we can see that our function does touch the x-axis in 2 places, so we're expecting to have 2 roots. The places that it touches the x-axis are negative, as we would have expected, and our factors are exactly the same numbers but opposite signs, so that if I put in a -3, here I would get -1, here I get 0, and the outcome is 0. We did a few more along those lines, and then I switched to something that is not monic. So for example, let's take a look at 2x squared minus 13 x plus 6. So here we had something that was not monic, and we can't easily factor we can't divide out the 2 rather and make it and force it to be monic. And so now I didn't really want them to see this screen, so but I didn't have a way to getting rid of it. So I just basically covered it with my hand and said, okay, let's go ahead and graph that. function. Oops. Still didn't do it. So there's 2x squared minus 13x plus 6, and factored it. And we can see now that we do have something that's factorable. We can see that the roots are both positive, and so we would expect our factors to have both subtractions in them. And now here we do have that this is 6, but this is 1/2. And so one of the drawbacks, I said, of using this is it may not give you exactly what kind of factor you're looking for. Now the fact that this one is 6, you can see that x minus 6 is one of our factors, but this is giving us 1/2, and if we put x minus 1/2, when we do 1/2 times 6, we'll get 3, not 6. And so we do need some manipulation in order to get the factored form. Now obviously if we solve for x, if we say 2x minus 1 equals 0, then we do solve for x and get 1/2. But again, I just wanted them to see that this is a very useful tool. It helps them find out what those roots are going to be. It helps reinforce what a root means, that it's the value, x value, that results in it being 0. And then we continued off of the calculator on the board, dealing with situations where it was not set up in standard form, and if we factored it and said, for example, we had x minus 2 and x plus 3 is equal to 10, how does that help us? And so they started to make that connection, and on their exam I didn't see anyone make that mistake. In addition to before the exam, the weekly quiz I gave this week asked them again some conceptual questions about what does the graph mean, what are the roots of a quadratic, and why is the 0 property helpful for us, that once we factor this, that one of these two things equals 0 and we can solve for x. So my students seem to enjoy using their calculators. I certainly saw them using them more in this last exam than I had in the previous 4 exams. So hopefully they start to see the technology that they have available and start making those connections. Thank you.